And remember our little chart, which you could probably see right here. You guys heard that? No? Okay. Welcome back to another episode of Study Time on the Active Recall YouTube channel. This episode is going to be the last episode in our subnetting series. The next series that we're gonna move on to is probably gonna be pertaining to routing. I might do some Cisco CCNA command line basics. This is the last episode with regards to subnetting, and it is definitely going to be a culmination of everything that we've covered in the last few videos. I'm particularly excited about this video because I came up with a way to share some of the study notes with you guys, and I'm going to be doing it through Patreon, or I'm probably just gonna send it to you guys when you ask, right? I'll just email it to you guys when you ask. But for now, I'm probably going to just fix up the notes, fix up the material that I'm using, include some links to this video, and moving forward, my study notes is probably gonna be containing the links to the videos that correspond to the materials that we used in the videos, right? So it's gonna be a nice, neat little package for anybody who's interested in just some concise notes to help them study for the CCNA, or if it's a topic that covers all of network engineering or whatever we're covering and you find it useful, you can always just take a copy of these notes and study from them. I'm trying to design it so that it's pretty straightforward, contains the basic topics, the basic concepts, so that you can just review it without having to dive too deeply into your textbook and get bogged down with a lot of the details. Now, on to the topic of this video. We are going to be analyzing existing subnets. I'm following the lead of this textbook, right? So that is the official cert guide for the CCNA 200 to 301, written by Wendell Odom. And I'm gonna be using a lot of terms that he uses in the book, like the magic number, interesting octet, and things of that nature. I think that he explains a lot of these concepts really well. So I'm gonna take my cues from him and explain it in similar terms in this video, right? So without further ado, let's get right into the video. So I just want to put a little disclaimer out there. The method that we're going to be using to analyze the existing subnets is going to be via the DDN notation. We're going to do it all through decimal notation. And if you're interested in learning the binary notation and the binary method, I highly advise you getting the book and reading into it so that you can understand it. The binary method gives you the full grasp of what's going on behind the DDN, the dotted decimal notation that we're going to be using in this video. And the reason why I'm using the DDN notation is to be able to calculate the subnet ID and the broadcast address, or whatever they're asking for on the exam, in as quick time frame as possible. Binary takes way too long, and I'm focused on getting the correct answers as quickly as possible. With this method, we might even be able to do some of the calculations in our head rather than write everything out or use pen and paper and everything. And I also have a cool little table that my professor handed to me, and I think it'd be of use to you guys. I mean, I don't really use it because I do some of these calculations in my head, and sometimes I count on my fingers and stuff like that. I might even use my calculator every now and again in this video to illustrate the concept, so just bear with me on that. I thought that I'd put that out there to you guys so that you'll know that this isn't the full scope of the concepts. Go back and read how we get these answers via the binary method so that you can get the full picture of subnetting and what's going on behind the scenes. It's actually pretty cool if you ask me, but you didn't ask me, so it is what it is. So let's get right back into what we're doing here. So as you can see, I have our study notes here. This is pretty much how it's going to look. right? I'm going to draw it all up in a Microsoft doc, and I'm going to, dress it up a little bit, and then I'm going to add some links at the end. Got a cool little QR code at the end so that you guys can just scan it with your phone and it'll take you to the video, and you can just follow along with the video using these notes, right? So you're gonna see the finished version of these, and I'm gonna make them available on my Patreon, or you can just simply comment and email me asking for this document and I'll send it to you, right? I think this is gonna be pretty solid for you guys because we're gonna get into that in a bit, because it's a way to bring a lot of succinctness to these study sessions. And if you like the way that I'm explaining the concepts, then this would be a great use or a great tool to use. So let's get into it. Now, as you can see, we have some brief review from past sessions, right? So this is just the basic concepts, right? We know all of this stuff already, right? This is from last time where I said, now that we know how to break down an IP address using classless and classful addressing rules, we can analyze a network and articulate its structure using a given IP address and subnet mask. So this is basically what we're going to be doing, but we're going to be getting some information with regards to the subnet ID and the broadcast address. These are just some of the basics. We know what classful rules are. We know what classless rules are. And if we want to review some of the classful rules, we have class A, first octet is between 1 and 126, n is equal to 8 bits. Class B, first octet is between 128 and 191, n is equal to 16 bits. Class C, first octet is between 192 and 223, n is equal to 24 bits. Now, this is going to be important when it comes to doing a little bit of algebra, and I have a problem for us that we're going to work out at the end, and you're going to see what I'm talking about when it comes to using a little bit of algebra and I guess filling in some of the variables so that we can answer the questions efficiently. First of all, we're going to review what is a subnet. A subnet is a part of a classful network designed by an engineer. Designed, right? And this is important to know when it comes to providing service to customers, right? If you have a customer that wants a maximum of 70 subnets and they want to be able to host 49 hosts, then you need to do a little bit of calculation, a little bit of designing to give the customer what they want, right? And you also want to account for some growth in the company, right? So this is where the base twos come into play. This is where knowing the IP addresses and the parts that it consists of come into play. The bits, the subnet bits, the network bit. This is where all of this stuff come into play so that you can design and structure subnets for a client or customer, right? We know that a subnet contains a range of consecutive IP addresses. This means that one IP address is not gonna be here and then another IP address is gonna be in a different network and belonging to the same network at the same time. No, we know that a subnet is gonna have a range of consecutive IP addresses, and we're gonna see what exactly that looks like as we progress through the study session, right? We know that each subnet holds 2 to the h hosts, where h is the number of host bits dictated by the subnet mask, right? We know that the subnet has 2 special IP addresses that are reserved for the subnet ID, lowest IP, and the broadcast address, the highest IP. And 2 to the h minus 2 tells us the amount of consecutive unicast, range of valid hosts, we're going to be using that term a lot, IP addresses that are between the subnet ID and the broadcast address. Very important details right here, right? So this lesson is going to revolve around being able to calculate subnet ID and the broadcast address, right? This is where this lesson is truly going to develop its core, right? Because we have to be able to answer these questions, right? So given an IP address and subnet mask, we can calculate some facts about the subnet in which the IP address belongs, which include subnet ID, broadcast address, range of valid hosts, and we can even describe the structure of the subnet via its group size. And you're going to see what I mean by group size in a second. We're mainly going to deal with this problem using some shortcuts, like I said earlier, which entails strictly or mostly using DDN format, because the binary format or the binary method is a bit longhand, and we don't have all that time when we're trying to take the CCNA and pass it, right? So we're going to mostly be using DDN formats, prefix formats, and a chart that one of my teachers have provided me with. So my teacher, as I said before, gave me this cool little chart that you can just write out by hand. It doesn't really take much memorization, but you can write it out by hand on a whiteboard or something while you're taking the test. And whenever you get certain questions on subnetting, you could look at this table as a reference to help you answer some important questions about a specific subnet. Again, I highly recommend understanding the binary method of calculating these values, because that's where the magic is going to be revealed to you, right? Behind all of this DDN stuff, a lot of the secrets of subnetting is going to present itself to you, right? So make sure you go back and you read the binary method for how to calculate a subnet ID, broadcast address, and the range of hosts, and all of the questions that we're going to be answering using the DDN, right? So nice, we're getting into some of the fun stuff, right? So we're going to be finding the subnet ID and broadcast address with easy masks. Now, what are easy masks? Easy masks are sort of kind of like the default masks when we're talking about classful IP addressing, right? But the easy masks give you all of the information that you want to know about the subnet ID and the broadcast address off rip. All you need to do is just look at the subnet mask, apply it to the IP address, and you'll get your subnet ID and you'll get your broadcast ID. You just have to apply just a little bit of logic and common sense and you're good to go. Easy masks present us with a straightforward way to calculate the subnet ID and the broadcast ID. They look like this, right? So we got 255.0.0.0, 255.255.255.255.0. That's I went ahead and skipped by mistake, but we just labeled this one right here, right? And then we have 255.255.0.0, right? So we got these three easy masks. They're easy. They're going to give us all of the information that we need right away. So let's use an example real quick. So if we have an IP address and mask of, this is what I don't like about Microsoft Word, right? So if we have this example right here, right? 172.16.5.7 with a mask of /24, which is, if we do our conversion, 255.255.255.0, right? What's going to be the subnet ID and broadcast address? Pretty straightforward, right? We're going to have 172.16.5.0, and the broadcast address is going to be 172.16.5.255. Now, you're probably wondering, how the heck did you get this, right? Well, I'm going to show you. It's pretty easy. Let's go over the rules for easy masks for calculating the subnet ID. So whenever you see a 255 in the mask, copy the corresponding value in the IP address to get the first part of the subnet ID. So as you can see, for example, we have this IP address with this mask, right? What we're going to do is we copy over the values of 172.16.5 because those are where 255 corresponds to in the subnet mask or the easy mask that we're provided, right? So we just simply copy it all over, and that's the first step. And this is gonna be super important when we're moving forward with the difficult mask, which is another Wendell-Odom terminology that's used in this textbook. The next rule is whenever you see a 0 in the mask, make the corresponding octet in the IP address 0. So if we have 172.16.5.7 and 255.255.255.0, we have 172.16.5.0 as our subnet ID, right? We simply replace the 7 with the 0. So we see how all of that works out. We're just simply copying it over, right? Just copy it over, and then when it comes to the 0, we have 0, right? So it's as simple as that. It's super straightforward with easy masks. Whenever you see a question with one of these masks right here, you just know, oh, that's easy money. That's easy money. You know that you just copy, you just follow the rules, and you're good to go, right? And that's with subnet, that's with finding the subnet ID, right? But what about the broadcast address? Well, the broadcast address is just as simple, right? So rules for easy masks for calculating broadcast addresses, right? Wherever you see a 255 in the mask, copy the corresponding value. It's similar to the first rule, that it's not even similar, it's the exact same thing with the first rule for finding the subnet ID. Now you're just doing the same thing here when it comes to getting the broadcast address. So wherever you see a 255 in the mask, copy the corresponding value. Pretty straightforward. Rule number 2, or step number 2, however you want to label it, wherever you see a 0 in the mask, write 255, right? So here we go. If we have 172.16.5.0 with a mask of 255.255.255.0, we would have a broadcast address of 172.16.5.255, right? Because we see that 0 is right here, right? Corresponds to that. Boom. We make that 255, right? And again, look over the binary method, because the binary method is going to show you what's going on behind the scenes of the DDN. Calculate the subnet ID and broadcast address by way of difficult mask. This is where things get really exciting, right? So let's just throw up a little, put it in a little heading form so that we can keep our point of reference, right? Let's make it, what color are we gonna make it? Let's make it red. Let's make it red so it stands out, right? Calculating the subnet ID and the broadcast address via difficult masks, right? What if the mask presents us with neither a 255 or a 0? What happened? What are we gonna do then, right? If we're presented with a problem like this, right? What are we gonna do? What are we gonna do about that? What if we're presented with a mask that says 255.255.255.224 and told to calculate the subnet ID and the broadcast address? What are we gonna do? Well, I'm glad you guys asked, right? So here we have a simple process that tacks on 2 extra steps to the other steps that we took earlier. And if you're following along with the book, I compressed the steps together. In the book, you're gonna find the subnet ID, right? And then he goes into a little bit of explanation and all that stuff. But in here, we find the subnet ID and then we jump straight into finding the broadcast address, because I find that, you know, it's a little bit more streamlined that way. And I mean, that's how we're gonna calculate it anyway, right? So when you read in the book, you're probably gonna find like a little gap if you're trying to follow along in the book or whatever the case may be. You might find a little gap, and that's because I decided to compress these steps so that we can calculate these as quickly as possible and as efficiently as possible. Remember, we're preparing for the exam. We're not sitting here trying to figure out too much of the theory stuff while we're trying to get the reps in for the exam questions. So finding the subnet ID, right? So step one, wherever there's a 255 in the mask octet, copy the value over, right? Simple as that. We're just gonna copy the value over, right? Wherever there's a 0 in the mask, write 0, right? But, and this is step 3, if a mask octet is neither 255 or 0, we're going to call this the interesting octet, right? As per Wendell Odom, right? He calls this the interesting octet, right? And it tells us where we really need to pay attention to, right? So we calculate the magic number, another Wendell Odom terminology, as 256 minus the interesting octet, right? Very important point, right? Because it's gonna set us up for finding the subnet ID, and then it's gonna set us up for finding the broadcast ID. So we set the subnet ID's value where the interesting octet is as a multiple of the magic number that is closest to the IP address without exceeding it. Now, this is where the whole group size idea comes into play, right? And it might be confusing now, but as you work through the problems, you're gonna see what we're talking about here. So let's take a step back real quick, right? What is the magic number, right? The magic number is going to be the group size, right? It's going to be the size of the subnet, right? Size of the group of IP addresses in that subnet, right? So that group is just gonna be, they're gonna be in blocks. They're gonna be in multiples. And you're gonna see as we work it out. Let's work it out, and I might even get a little drawing in. The next step, finding the broadcast address. And I know I didn't really work the problem out yet, but we're gonna work the problem out in a second. Step 4, wherever there's a 255 in the mask octet, copy the value. Step 5, wherever there's a 0 in the mask, write 0. Step 6, wherever there's an interesting octet in the mask, add the magic number to the corresponding value and subtract 1. In other words, it's plus magic number minus 1. So we went through all the steps. Let's work this problem out, right? We're gonna be working this problem out. Let's go over to our board right here. I should have wrote it out. So what was it? It was 192.168. Let's check real quick. .5.7 with a subnet mask of that, right? So 255.255.255. Let me just make sure. 224, right? Pretty straightforward. We just writing it out, right? Thankfully, they gave us the subnet mask and DDN, so we don't have to do no prefix translations and none of that stuff. So here we go, right? We want to find, let's change the color up a little bit. Where's red? It's my favorite color, right? Okay, so let's find the subnet ID, right? And the broadcast address. Okay, so what's the first thing we're gonna do? Step 1 says, wherever we see a 255, we just copy the corresponding value over, right? So we see 255 in the first 3 octets. So we do this, 192.168.5, right? Now we see that we have an interesting octet right here, right? So now we have to calculate the magic number, right? So the magic number is simply 256 minus 224, right? Which is going to be 32, right? 32. So now we know that the structure of this network looks kind of like this, right? Kind of looks like this. And this is where we're going to get our little drawing in. So we know that the first subnet is going to be, right, .0, right? We know that the next subnet is going to be dot 32. And we know that the next subnet is going to be dot 64. Like, you're kind of seeing what's happening here, right? It's multiples of it, right? Dot 96, right? This is what it's looking like. And I don't feel like doing the math. What is it, 128? I think it's 128. 128. Like, you're seeing it, it's starting to break up. These are the subnet IDs, right? So let's move on to the next step so that we don't skip a beat, right? So we calculated the magic number. The next step, let's figure out what the next step is. Look at what the next step is, because I'm getting a little sidetracked there. So if a mask octet is neither 255 or 0, we're going to call this the interesting octet as per Wendell Odom, right? We calculate the magic number as 255 minus interesting octet, which is what we did. Set the subnet ID value where the interesting octet is as the multiple of the magic number that is closest to the IP address without exceeding it. Now, what does that mean? What that means now is we see that we have 7 right here, right? And where will we find this IP address within this little picture we have right here, right? We're gonna find it somewhere in between here, right? So we're gonna find it. So that means that the subnet ID that this IP address belongs to is 192.168.5.0. Now, let's just for argument's sake, or just to understand this little drawing right here, because this is how you're kind of going to visualize the subnet setups, right? Let's say that the IP address, say we're given this IP address, right? Let's say we're given, where is the IP located? Which subnet is the IP located, right? It's going to be here, because this number right here, this IP address right here, falls within this range. So we know that it belongs to the subnet ID of 192.168.5.32, because we know that the group size given this subnet mask right here tells us that it has the group size of 32, and it can be found within that range, right? So we're gonna use the subnet ID, and we're gonna figure out the rest of the calculation. We're gonna follow the rules as it pertains to calculating the broadcast address. And this is where it's like this streamlined process, right? If you read the book, it's gonna be a little bit different, but yeah, let's keep moving forward. Now that we know that the subnet ID is 192.168.5.0, what do we do now, right? Wherever there's a 255 in the mask octets, copy the value, and wherever there's a 0 in the mask octet, write 0. Wherever there's an interesting octet in the mask, add the magic number to the corresponding value and subtract 1. In other words, it's plus the magic number minus 1. So let's go over that real quick. So now, let's just copy this over, right? We see that it's, once again, it's 192, because we're copying it over, because we see a 255 in the first octet, 255 in the second octet, 255 in the third octet, right? So we're just going to simply copy that over. 168.5. Now we need to find that right there. How are we going to do that, right? We're simply going to add the magic number, or the group size, if you will, and we're going to see why that makes sense, and then we're going to subtract 1, right? So it's going to be 0 plus 32 right? Order of operations, right? You guys know what order of operations is, right? So this is going to be 32 minus 1, which is going to give us 31. So it's going to be 31. That is going to be our broadcast address. And that makes sense, right? And here's why. Because remember this equation right here, 2 to the h minus 2, right? What did we say this 2 was in the last video? That 2 was the subnet ID and the broadcast address. Broadcast address, right? So that's gonna pretty much provide the boundaries of the subnet, right? So right here we can see that this is the subnet ID, right? And this is also a subnet ID, but the broadcast address is actually right here, right? That's going to be the broadcast address, right? So we have a nice little, we have these boundaries: subnet ID, broadcast address, subnet ID, subnet ID, subnet ID, subnet ID, broadcast address, subnet ID, broadcast address, subnet ID, and then we have the broadcast address and whatever that next subnet is. That's our first problem, right? Pretty straightforward. And let's move on to our next example so that we can fully grasp this analyzing of existing subnets, right? Our next practice problem, right? It's going to be very similar to the last problem that we have, but we're just going to change one octet. So 192.168.5.77 with the mask of 255.255.255.224. With this, it's pretty straightforward like the last one, right? So we could start to go a little bit faster. Subnet ID is going to be 192.168.5, and then we need to figure this last bit out, but we know the magic number is going to be 256 minus 224, which is equal to 32, right? So we want to know where this IP address falls in our nice little subnet structure picture, right? We got 0, 32, 64, 96, 128, right? Right? Similar to that little picture right there, right? So where does this IP address fall in this chart right here, in this little drawing right here, right? This IP address falls right here. So that means that the subnet ID is 192.168.5.64, right? As defined by this right here. This is where they're falling, right? Now, what is the broadcast address? So the broadcast address, and we're gonna go fast here, 192.168.5.64 plus 32 minus 1. Remember, order of operations going to be 96 minus 1, which is equal to 95, right? So dot 95, right? And how did we get that? We're going to use wherever this interesting octet is. We're going to use that number, and then we're going to add to it the group size, or the magic number that we calculated, which was right here. And then we're going to subtract 1, right? And that's going to give us our broadcast address. And that broadcast address is the end of the subnet, right? It's the end of the subnet. Remember I told you it's like having borders, right? You got the subnet ID, and then you got the broadcast address here, and then right after that, the next subnet starts, right? So that is the broadcast address. Now, if the question asks for the range of valid hosts, that means what's going to be the consecutive IP addresses that exist within that subnet, right? So it's simple as this, right? We know that, let's just put range of valid hosts. These are going to be the IP addresses that are available for the devices that want to log onto your subnet, right? It could be the HR department, it could be the research department, the engineering department, whatever department it is. These are going to be the IP addresses that are available for the devices in that department, right? So now we have the first IP address is going to be 192.168.5.65, right? And it's going to be to 192.168.5.94, right? Which is right before this, which is the broadcast address, right? And 65 is right after the subnet ID. Again, no host can have the subnet ID as its IP address and the broadcast ID as its IP address, right? Those are reserved for, like I said, the subnet ID and the broadcast address, right? Those are reserved. These right here are reserved always, right? So that is subnetting, right? That's the crux of subnetting. That's how we start. That's how we start the subnet, right? And all of this contains information that you can use to go to a company and, I guess, set up their IP address, or on your own home network, you can start to think a little bit more critically about how you're assigning IP addresses, where you're wasting IP addresses, etc., etc. And this is where the whole pizza analogy thing comes in as well, right? You can think of each of these as a slice of pizza, right? Whatever this is, that's a slice of pizza, right? That's where that whole idea comes from. Wendell Odom uses the example of sandwiches, and it makes appropriate sense because we see this as like a straight line, linear type of situation, like one of those, those big long heroes that you bring to work for like a meeting or a potluck or whatever, and then you just slice them up because no one person can eat a whole big ass sandwich. I mean, some people can, but normal people who aren't gluttonous can not eat a whole sandwich, right? So let's move on. Let's do one more problem. So here we have the IP address of 165.245.12.88 with a /20, right? So this is where our conversion magic is going to come into play. So we have this, right? And we can use our fancy little table. Let's use our fancy little table to tell us what's going on, right? So my professor gave me this little table right here, right? And what does it tell us? It tells us that /20, it tells us /20 is right here in the third octet, which corresponds to the CIDR notation of 240. So let's do our little conversion magic and let's see if that adds up. So let's do binary first, right? Because binary, we need some practice with that, right? So binary will tell us the whole story. So we know that it's 20 ones in a row, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? So that's 16 ones. So we're gonna have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, right? And remember our little chart, which you could probably see right here. You guys heard that? No? Okay. Anyway, what does this correspond to, right? As per our chart, right? And we could go to our little table that our professor gave us, right? Oh, it corresponds to 240, right? Nice. So we know that this is 255.255.240.0. Now, you know, this is way too slow. We need to be able to look at this and automatically know that that translates into this off rip. We need to know that, right? But you can either count on your fingers like I do, use a combination of the binary magic and counting on your fingers like I do. I know that it's 128, 192, 224, 240, and that's what, 4 ones lined up nicely. Boom. That's gonna give me 16 ones in a row plus 4, which is gonna be, with that binary octet, is going to translate to 240. I already know all of this by heart in my head, right? So this is going to be a lot faster if you already know everything off rip, or if they'll allow, you can write this whole table out on the whiteboard that they give you for the exam. Whatever scratch paper, you can just write this out real quick, I believe, and then you just leave it there for reference when you come around to a problem like this and the next problem that we're going to be doing, right? So let's move on, because we haven't even scratched the surface yet, right? Or did we? We might have. Okay, now we have this IP address, right? 165.245.12.88/20. Let's do some calculations. Right? What's the subnet ID? What's the subnet ID? What's the broadcast address? And what is the range of valid hosts? So the subnet ID is going to be, let's copy everywhere where there's a 255, 165.245, right? And then where there's a 0, we're gonna put a 0, right? Boom, right? Straightforward, right? Now, the next thing we're going to do is calculate the magic number. So that's going to be 256 minus 240, which is equal to 16. Now, we have the interesting octet corresponds to this right here. And we know by virtue of the whole group size thing that this IP address is going to fall within the range of the subnet ID of 165.245.0.0, right? Let's do our structure picture again, right? This is that subnet ID. 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 And I don't know what 48 plus 16 is. I don't know. What's that? 54? I don't know. 54? 54? 64? 64? I think it's 64, right? I can't add, right? So we know that this subnet ID is going to be here, right? Pretty straightforward. That's easy peasy. That's easy, super easy, right? Because it falls between here, right? We know that it goes from left to right when it comes to the IP addresses. They're given out consecutively, We know it's not 16 because this is the group size boundary, right? This is a group size boundary, and we know that the IP addresses are addressed from 16 up to the last valid host of this, which is going to be 30, right? Right? And as you get more advanced in subnetting, you're going to know where that 30 came from. But you know it's going to be, the addresses are going to be, not from 16, sorry. It's going to be from 17 to 30, right? So boom, we got our subnet ID. Now we need broadcast address. What is our broadcast address, right? 165.245, right? Now we're gonna follow the rules again. We're gonna follow the rules once again, right? Wherever there's a 255, we simply copy over the octets, right? Now there's an interesting octet right here, so let's leave that there for now. And then we see a 0. Wherever there's a 0, we're gonna put a 255, right? There we go, right? Now we gotta figure out the interesting octet, right? So what's the group size? 16. So we're gonna add this, right? We're gonna add this up. 0 plus 16. Order of operations minus 1. This is gonna give us what? It's gonna be 16 minus 1, which is equal to 15. So we know that to be the broadcast address, right? Let's figure out the range of valid hosts. And we know it's simply gonna start with 165.245.0.1 and go all the way to 165.245.15.254. Boom. That's it, right? Because that's going to be the last number here, right? It's going to be the last number right there. Simple as that, right? To see that whole group size, that whole range of IP addresses, it ends here as the valid hosts, that is. And again, these are going to be the IP addresses that you're going to assign to whatever department that this subnet belongs to. Say this is HR. That's going to be the last, I don't know, say that's Karen's computer. I don't know, that's Karen's computer, right? And then this is engineering, and this might be research, right? And this might be management of some sort, right? These are all different subnets, right? So now, what if you come across this question right here? What subnet mask would you use for the 172.17.0.0 network such that you can get 70 subnets and 490 hosts per subnet, right? So this is where I was speaking about, algebra and just basically using the information that the question gives you to kind of like fill in the blanks, right? Now with this, you have to know and be familiar with your base 2 exponents, right? So I'm looking at this right now. Let's just off rip, let's just look at, it says such that you can get, let's start here, 70, 490 hosts per subnet, right? I know off rip that I can use base 2 to kind of get as close to that number as possible, right? And I know there's gonna be some sort of waste somewhere, but that's actually good because it gives the company that we're subnetting for some room to grow into those subnets and hosts therefore, right? So here we go. Let's just gather some information about this network, right? We know that N is equal to 16. Why, right? And this is from the last video that we did, because this right here tells us that it is a class B network, right? And we know the class B network has 16 bits, right? What else can we pull from the information here, right? 2 to the what is going to give us something close to 70. So let's start with 2 to the 5, right? We know that 2 to the 5 is going to be equal to 32. 2 to the 6 is 64. We're getting close, right? Let's do another one. 2 to the 7 is 128. Yeah, I think that we're gonna use 128, right? So what is that telling us, right? So remember, 2 to the S is equal to how many subnets, right? It's equal to the amount of subnets, right? And these are simply the subnet bits. Now we can start to think about this in terms of classful IP addresses, which is what we're doing, because initially we started talking about N, right? In bits, which means that there's going to have to be some sort of subnet part to it, right? There's gonna have to be a part to it that can tell us more about the network part of the IP address or the network, right? So subnet bits, they're gonna be equal to 7 because it gives us 120 subnets, and this company wants at least 70 subnets, right? Now, we needed to have 490 hosts per subnet. I mean, the rest just fills itself in pretty much, because now we have n plus s is gonna give you your prefix, right? That makes sense. Boom. So it gives you 16 plus 7 is equal to 23, right? Now, we know that an IP address is 32 bits, right? So now we can just do h is equal to 32 minus p. 32 minus 23 is equal to 9. And we know that host per subnet is 2 to the h minus 2, which is going to be equal to 2 to the 9 minus who? And what's 2 to the 9? 512 minus 2 is going to be equal to 510. So we know that since h is, I'm running out of room here, h is 9, that gives us 510. 510 is more than 490. So that gives us, that all works out, right? It gives us enough room for this company to grow with its 128 subnets and 510 hosts per subnet, right? But they didn't ask for all of that, right? They want to know what subnet mask. I just got excited there. What subnet mask would you use for 172.17.0.0 network such that you can get 70 subnets and 490 hosts per subnet? Now, you can think of the subnet mask as, if you think about this as a pizza, right? You can take that little roly thing, right? and cut the pizza up. That's basically what we're doing with the subnet mask, right? And they want to know what's the size of the slices that we're making for the slices of pizza, right? I did a bad analogy right there. See, I tried to do something and it just didn't connect. But let's see. What is /23? What is the mask that's the slash mask, and that tells us that 23 ones are turned on, right? But let's have some fun with it, right? We know that it's /23, right? So it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's 16 ones. Then it's gonna be 1, 2, 3, 4, 1, 2, 3, right? So, oops, 16, yeah, 1, 2, 3, and it's gonna be 0, 1, 2, 3, 4, 1, 2, 3, 4. Almost lost my train of thought right there. All those ones, right? So we know that this is 8 plus 8 plus 7 plus 0 gives you 23. But now, what is the actual mask for it? What is this convert into, right? So we know that this is 255.255 dot what? So I like to count on my hands, but let's go to the chart that my professor used, because, right, what is /23? We know that /23, it's in the third octet, so it's 254. Simple and straightforward, easy peasy, right? We know that's 254, boom, right? But I like to count on my hands, so 128, 192, 224, 240, 248, 252, 254. 7 ones turned on. These are 7 ones that are turned on. 254, boom. So that is the mask that they're asking for. Pretty straightforward, right? So that's it. We found the first and last valid host. We found the subnet ID, the broadcast address, right? And we, to the best of our ability, used everything that we could use from our previous videos to calculate the subnet ID, broadcast address, and the range of valid hosts, right? So that's pretty much it. We covered all of the necessary topics in order for us to answer these questions efficiently and quickly, and I'm gonna remind you once again, read up on the binary method so that you can easily understand the concepts going on behind the DDN, right? The DDN notation, you can, as you can see, draw things out, draw the structures and everything. And whenever you make a mistake, you can kind of like backtrack and correct your mistakes like that and everything. But really look into the binary method so that you can fully grasp the breadth of the subnetting topic, right? I had a lot of fun doing this subnetting stuff, and as you can see, it's not as hard as some people say it is. All you need to know is some base 2, some basic formulas. They give you 2 of them, and you just need to know the structure of these networks in order for you to make any sense of it. I think what you should do when it comes to subnetting is think about what it aims to do, right? When you're subnetting, you're trying to break a network up into pieces and feed them to a company, right? You're working for a client, or you're working for some company, and they want you to hook up their company with various subnets that go to each department that they have. Like in the video, we talked about using subnets to give to HR, to engineering, to research, or whatever it is, access to the network, to the internet and everything. And we're doing that for security purposes. We don't want HR to see what research is doing and research to see what engineering is doing and everything. We want everything split up nice and neatly, right? And just for bonus, just for, talking sake, right? We can actually think of all of these subnets happening within a switch, right? We can think of these subnets happening within a switch, a managed switch that uses VLAN, right? So that's pretty much it. And if you want to review and watch the whole series, click right here, and I'll talk to you guys next time. Peace.